before we can get into the actual proofs, the basic idea of walking through a proof. The nice thing is this going to use algebra to kind of introduce this concept of walking through something and steps of something. So here are our first properties. Properties of equality. Guys, an equation has two sides that are equal. When you do something to one side, you've got to do it to the other in order to keep it equal. So you have an equation like this. A minus 2 is equal to 5. Okay? What do you do to both sides to solve that? Add 2. And when you add 2 to both sides, the two sides are going to remain equal to each other. That's what the whole property says. If you add the same thing to both sides, it's still equal. Okay? The next one's going to be the same exact equation, but a plus 2 equals 5. Instead of adding 2, because this is already a plus 2, you would go through and minus 2, which would make it a equals 3. But the sides are still equal because you're using that rule that if you subtract something from both sides, it stays equal. Multiplication looks like this. If we've got a over 2 equals 5, we're just using the same numbers every time, guys, to make it easy. Okay? A over 2 equals 5. You are going to multiply both sides by 2. That's going to make it a equals, and 5 times 2 is going to put it at 10. You multiply both sides by the same number, that means it stays equal to each other, and you can do that, guys. The reason you can't multiply one side, you can't multiply just the other side. You got to do whatever you do to one side to both sides. That's why it's called a property of equality. So the addition property of equality says you can add. Subtraction property of equality says you can subtract, etc., etc. The last one looks like this. If we have something that looks like, what I put, 2a equals 10, same numbers, just working a little backwards. What would we do to both sides? Divide by what? Divide by 2 on both sides, and a would equal 5. Okay. Those are the 4 properties of equality. We're going to use those in equations to solve them. You're going to have to name those properties. So those are usually ones that people don't have trouble with, then mainly because they're exactly what they look like. You're adding to both sides, it's the addition property of equality. You're subtracting from both sides, it's the subtraction property of equality, etc. The next 4 are ones that you may or may not know the names of, and these may be ones that you need to actually make flashcard for, get something so you know this information. Please, please, please understand that these things that we're going to have on this next one may be stuff you don't know the names of already, and you're going to need to. Okay, so this first one, A equals A. Guys, something is equal to itself. Reflexive property. Something is going to be equal to, it's like reflective, but don't spell it like that, please. Like a reflection in a mirror. Something's going to be equal to itself. When you see yourself in the mirror, same thing, you've got that there. So A is equal to A. There's no solving it, no doing anything. It just says that something is equal to itself. Okay? Symmetric property of equality, guys, you use this all the time. If you have an equation that looks like this, and it's B equals A, and you got to have the alphabetical order one in front, you just switch them, and it's going to be A equals B. Why can you do that? Because by symmetry, the two sides are exactly the same. So if you flip it over, they're still going to be the same. Alright? Kind of like when you look at something, y'all ever do those pictures where you took it and you put stuff on one half and you folded them together and you made that picture with it? That's the idea, is that the two sides are the same, so you can flip it and it will still be the same. Okay, now the transitive property is one that most people can identify easily if you'll learn that it's the long one, and this is what it looks like. It says if A equals B and B equals C, then, and it's the only one that looks like this, guys. So if you'll recognize that it does this, transitive is an easy one for people to get the name of. Just learn the name of it, you'll recognize it. Then, guys, look, do you see that they both equal B? If they both equal B, then they have to do what to each other? Equal each other. That's exactly right. So it's going to be if A equals B and B equals C, then A equals C. Because you can think of it like if A equals 5 and 5 equals C, then they're both going to be 5, so A equals C. Okay, the last one. If we have this, A equals 7, and we have a problem down here that says AB, and we replace the A with a 7, and we make, well, we don't need the parentheses, I apologize, and we make it 7B. Y'all see that what we're doing, we're taking and we're substituting the 7 in where the A was. That's called the substitution property of equality. It does not change the problem. It's still going to be the same, but it is saying that that is still going to be equal. Okay? AB is equal to 7B because we're substituting in the value of A. Okay guys, that's 8 properties, 8 that you're going to have to use. Let's see if we can name them when we get to the things that we have on examples. Anybody have any questions about those 4? Because they're a little bit different. We're good on them? Okay, here we go. So, here is the name. Oh, I apologize. I'm sorry. I didn't see your hand. Go ahead, please. Where the what? On which one? On substitution. So what you've got is, let's say it was, I'm trying to think of one that we could do. Let's do it with a plus or minus. So if I said A equals 7 and we had A plus B, I would only be replacing the A, right? Because we only know that A equals 7. So it'd be 7 plus B. So it has to stay a B because we didn't have anything to plug in for it. So down here, I'm only replacing the A. That's going to be a 7, but it's still going to be a B in the back. So it's just 7B. Okay? Anybody else? Okay, here we go. Let's see if you can identify these. Guys, here are the problems. Name the property that fits this. It says 6 plus 2 equals 8, and 8 equals 4 plus 4. Therefore, 6 plus 2 equals 4 plus 4. Guys, they're both equal to 8, so they're both equal to each other. Which property? Look on your list. You've got the list. Transitive, that is correct. So transitive property. Oh, guys, geometry is really weird about abbreviations. The ones they'll let you do, I will absolutely let you do as well. PROP is absolutely acceptable for property. Transitive property of equality, they will let you put the equal sign. So put it. Make your life easy. Make it shorter. If you want to write of equality, you can. Yes, ma'am, please.
What if we just put trans?
They will not take it. Thank you for asking me that. Some things they'll take, usually the actual name piece of it, they will not let you abbreviate. That's a very good question. Guys, they're really weird about what they'll let you abbreviate and what they won't. Okay? Transitive property of equality. For the next one, if 5 equals 1 plus 4, then 1 plus 4 equals 5. Do y'all see what they did? They took and they just switched it. Which one is that? Did we subtract anything? Symmetric is absolutely correct. That's it. Symmetric property of equality. Good. Keep trying, guys. That's it. Symmetric property of equality. Symmetric property of equality. Okay. So we're taking that x equals 3, and you see where the x was originally, and now the x is replaced with the 3. If we replace the x with the 3, what are we doing? So yeah, substituting. That is exactly correct. Substitution, property of equality. Substitution, property of equality. Okay, now the ones that are set up like this, they don't actually show you the step. They just show you what it was and what it is now, and you have to see what it would do. What would they have to do here? What do you do to that -3 to make it go to here? Add. And if you add 3 to both sides, that is the addition property of equality. There you go. Okay, last one. If you're going to go through and do this, you're going to go through and you're going to deal with multiplication. What are you going to do to both sides? Ooh, come on, guys. What do you do to get rid of this 6? Divide. If I divide both sides by 6, that would be the division property of equality. Oop, equality, not symmetric. Okay. Anybody have any questions, concerns, anything else? Okay guys, I need to mention something. Every single one of these properties will also work. Every single one of these ones that we've done before will all work when you're dealing with congruent as well. Okay? So if you see a congruency sign in the middle, instead of saying of equality, you would say of congruence and just put the congruent symbol of it. But it's the exact same thing. You just write of congruence. You won't see it a lot, but you will see it sometimes, so I need to make sure you know that it works for that as well. Okay guys, so today we introduced the concept of a proof. Proofs are going to be a big thing in this class. We're not going to do them every day, but they are going to be a large part of what you deal with on the EOC, and a proof is taking something and going through it and giving the steps for what you do every time. You did it in algebra and your teacher said, tell me why you did this step. Why did you do this step? But now we're going to apply it with the algebra and the geometry format of a formal proof. Before we get to that, we do want to talk about the distributive property. Okay, it's one we haven't seen yet. We just want to make sure we get it down. So distributive property looks like this. If you have something on the outside, we'll call it A, and then two things on the inside like B plus C, the distributive property allows you to multiply that across the parentheses. Okay guys, AB, when you multiply A times B, all you do is put it right next to each other. It'd just be AB. So what would the next part of it be? AC. Perfect. Can you add those together? Or not? Can't combine like terms because they don't have one has a B, one has a C. You can't combine those. That's where you got to leave it. That is the distributive property. That's what it looks like. Okay? It's the last of the properties that we're going to use in our proofs today. We're going to start by getting a definition for what a proof actually is. Guys, it's not complicated. Okay? We're just trying to prove that something is true. So it is called a convincing argument. Actually, we need an E in there. Argument. A convincing argument, and this is key, that uses deductive reasoning. And we're going to talk about deductive and inductive reasoning later, but what I'm just going to do right here is put rules underneath this. Guys, deductive reasoning is like following the rules. When you come to a stop sign, most of the time, you stop because you know if you don't stop at the stop sign, you could get a ticket. Because the rule is you're supposed to stop at a stop sign. If you go through the stop sign, you could get a ticket. So your mind is saying the rule says you're supposed to stop, so you stop. That's deductive reasoning, basing your choices based on rules. And this is going to be arguing using a set of rules. So this is a two-column proof, guys, right here. I'm not going to define it. This is what it looks like. It's going to have a given statement. It's going to have a proof. It's going to have a list of statements here and a list of reasons. Okay? On this problem, starting off with right here, 2x plus 3 equals 9. That's the given. That's the equation in this case. What we're trying to do is solve it to make us prove that x equals 3. And this is the process that we go through to get there. Guys, if you went through here, this would be the first one. And guys, how do we know that's the equation? Because they gave it to us. So all we do is write down given. The next one, what would you do to go from here to here? What would you have to do to go from the 2x plus 3 to just have the 2x there? Subtract 3. And what do we call that step? Subtraction property of equality. It's already written there. We're just going over it. We got some examples in a minute to do. This is just us going over it. For the next one, to go from here to here, you would divide both sides by 2, which means that x equals 3. Oh, excuse me. Stupid calendar's still connected. We can't figure out how to start it. We're just not worried about it. Now, since we divided, it's the division property of equality. Guys, look though. Do you see? To go from here to here, what happens from here to here, that step goes right next to it. What happens from here to here, goes right next to that step. Right? It's what happens as you go down to that step that you put on that line. Any questions? See anything? Okay, guys, here we go. Let's go down to this next step. These are our examples today, and for some reason, again, my example numbers are all like flying away. I don't know where they're going. We already had example numbers 1 through 5, so this is going to be example number 6 and example number 7. I apologize for that. For some reason, when I import them into PDF form, random ones just disappear. We can't figure out why it's doing it, but it is. Okay, guys, we got an equation. We want to prove what it solves to. Here's the equation. Guys, how do we know this is the equation? Because it was what? Given. They gave it to us. You write down the word given. How do you know to look there? Because it's given to us up at the beginning. If it's what's there, you write down given. You got a question, sir?
No.
Okay, go ahead. Okay, for the next one. What are we doing to multiply across a parentheses? What did we call that? It's on your paper. Which property allows you to multiply across a parentheses? Look through there. It was actually the last one we did. That's the distributive property. If you have a number outside of a parentheses and you multiply it across, that is going to be the distributive property, P-R-O-P. You can abbreviate that, and that's all you need to put there. Distributive property. Now, we don't write up equality, guys, because we're not distributing across an equal sign. We're just distributing across a parentheses. So it's just the distributive property. It doesn't need to say of equality. Yes? I don't know. Let me look. What do we do from here to here? What happens from step 2 to step 3? We would, yes, minus that 4, yes. So that would make it that subtraction property of equality. Again, you can abbreviate that stuff, P-R-O-P, of, and an equal sign. That's all you need to write. The biggest thing is writing down the word subtraction. Okay, and for that last step, what are we doing to both sides? Divide. Perfect, exactly right. Division, property of equality. Okay, guys, they're using algebra to make it so that you can start the where'd it go? You got it? Is it this pink one that's up here by him? Oh, sweetie, can you get her pencil? It's all by your foot. It went way up there. There you go. Okay, now they're going to use geometry to combine the geometry and the algebra so you can see how it connects. Guys, this is one we did a lot, so let's look at it. It says xz plus zy equals xy. Okay, guys, let's look at the picture. Xz plus zy equals xy. Now we have an informal name for that. What is that called when we do that? What's that called? This plus this equals this. Someone said it. You got the right idea. Part plus a part equals a whole. They don't have to be halves, so I can't say that. They could be like 5 and 3 equals 8, so I got to be careful about saying halves. But yes, it is the part plus a part equals a whole. What's that really called? We don't write down part plus part equals a whole. What are these things called, guys? These are what? Anything that has endpoints and the points in between. You got to know what that's called. What is that? It's not a line. It's a what? Someone said it. I don't know where it came from. It has an S, and I can't tell where it came from. Oh, really, guys? Guys, part of a line that has endpoints. What's that called? Ooh, that's called a segment. Y'all got to know that. Segments are part of a line that have endpoints. It's one of the vocab we did already. These keep showing up. They'll show up the whole time. There's a good chance for you to see. You got to know those vocab words. So here we go. It is called the segment addition postulate. Segments addition postulate. Yes.
If this N3Y, is that a segment?
Okay.
Like, how would you know this is a segment?
Oh, Because it has endpoints, period. If it has an endpoint, the points in between and another endpoint, that's a segment. Yep. If it doesn't have arrows on the end, that's when it's a segment. If it has one arrow, what's it called, guys? One arrow makes it a what? If it goes one direction, what's it called? Ooh, come on, guys. What's this? Array. Thank you. Array. If it's like this, it's a segment, and if it's like this, then it would be a line. Good. It's a good question. Okay, here we go, guys. If you replace all the letters with all the numbers that are up here, replacing is what? What's that called when you replace something? Substitution. Substitution. Property of equality. Substitution, property of equality. Okay, guys, do you see we're not really doing anything? We're naming. They're going to get you to do some and names. This is mostly about naming, learning how to name these steps, identifying these properties. Okay, to go from here to here, we multiply across parentheses. We already did this one once, guys. You should see this now. If you multiply across parentheses, what is that called? Distributive. Good. Distributive property. Nice. Ooh, we haven't had this one yet. We've done it in class. We haven't done this we haven't talked about this today. What lets me take those and get 5x? Yeah, there we go. Combining like terms. Very nice. Combine like terms. Now, listen to me, guys. If you say combine like terms when it's combining like terms, I'm not going to take off. As long as you know what the concept is, I'm not going to get you on, ding you on whether you put it in what tense or whatever it is. As long as you get the concept that what we're doing is taking two like terms and putting them together, you're good. Combine like terms, combining like terms, I don't care. Okay, that's an English rule. We'll worry about that in your other classes. Okay, from there to there, we do this. So what would be next? Good. Subtraction. Property of equality. Oh, I tried to write the word all right. Put the symbol. It's quicker. Much quicker to put the symbol, guys. And then the last one on this page, what is it? That's all correct. Division. What?
Property of equality.
There we go. Division property of equality is exactly correct. Okay, guys, so we are going to apply this and do problems today that are just like this. You're going to be naming the properties for me, walking through the basic idea of a proof, just identifying some properties, just like you did on the earlier examples.